Okay. Here's some further examples on finding the volume of a solid of revolution by cylindrical shells. This is the extra examples I promised you guys I would give you on this method, and I did update the worksheet and I sent you guys that information in Canvas. So let's go over what we're looking at here. Okay. You have a bounded region by the parabola y is x squared, y equals 0, which is your x-axis, and the horizontal line, vertical line x is 1. So you see this in the graph here, and we have that region. We created our approximating rectangle, and as you guys can see, as you revolve about the y-axis, you create the cylindrical shell. And we use the formula for cylindrical shells here, that v equals the integral of 2 pi r h dx. So the key points we need is the radius and the height. And that's the radius of your cylindrical shell. So as you look at these two values here that represent your radius, it's always the right value minus the left value that we have in here. So you'll have here for the radius x minus that 0 there. Okay, so here's our next value. Here is 0. That's the position. And that's going to be how we get the radius simply being x. So your radius here is x. And that's how we find a horizontal distance. And how we find a vertical distance, notice for this particular x, if you want to call it that, it's going to be the y value. So for vertical distance, which represents your height now, it's the height of that approximating rectangle for that cylindrical shell. Well, that's the top value, which is y, minus the bottom value again. So this point minus this point, which will simply be y. And y is going to be the x squared. So you get the radius, which is x. You get your height, which is x squared. And then that goes into your integral here for the radius and the height. And notice that you're going to integrate from 0 to 1 here, because the value of x goes from 0 to 1. And that's what's in this picture here. So your volume now will be the integral from 0 to 1, 2 pi x squared dx, which is that integral from 0 to 1, 2 pi x cubed dx. We can pull out the 2 pi x cubed dx. We can integrate x to the 4th over 4, which gives us pi over 2 x to the 4th. And we can evaluate now. Pi over 2, 1 to the 4th, minus pi over 2, 0 to the 4th, not squared. And so we simply end up with pi over 2. So there you go. There's an integral. Represents volume by the cylindrical shell method. And, this is rotating about the y-axis. So you notice we get a cylindrical shell. We need the radius and the height. The key, though, is just finding those two things, radius and height. So if we go to the next kind of question here. Again, notice we revolve about the y-axis. And this time you have a curve. You have a parabola represented by the blue curve. And you have a line represented by the green line. Sometimes referred to as a curve here. So you have this parabola that opens down. you have that line, and here you go. So the bounded region they're referring to is right in here. And again, you can see here, just by the geometry, that you go through this line, x is 0, x is 3. And you have, again, the approximating rectangle in this picture. When you revolve about the y-axis, on the other side, you can see the region, or maybe even this approximating rectangle here. Create your cylindrical shells. So this is volume by cylindrical shells. And again, V is the integral 2 pi RH dx. But you're going to go and integrate from 0 to 3 here. This is what your x values vary from, 0 to 3. Now again, the key here for this question here is finding the radius and the height of your cylindrical shell. So as you can see here, for your radius value for that shell here, right, radius is this distance from 0 to x. So that your radius again is the right value. Guess we'll put that here. That x value minus 0 here. Okay, so you're looking at the distance between these two locations, which represents that radius here that they're talking about. Here's my r. X minus at 0, so here's my radius value. Radius is x. And then your height value. The height of that cylinder. So for this particular value of x here, the height in green is what we're trying to find now. From this point to this point for your particular x value. And that's y top minus y bottom here. So for the height, y top minus y bottom, where the top curve was in blue, that's your 3 plus 2x minus x squared minus the bottom curve in terms of the y variable. So if you have x plus y is 3, this means y is 3 minus x. So you get 3 minus x. So let's really take a look at that detail for our height. Our height is the top value minus the bottom value. So 3 plus 2x minus x squared minus that 3 minus x here. And that's going to be my height there. So your height becomes 3 plus 2x minus x squared minus 3 plus x. Doing our algebra here, it looks like we're going to get 3x minus x squared here. So this is our height. So we're looking at measuring this distance here, total for the height of that cylindrical shell. It's the top value minus the bottom value, points on those curves here. Okay, radius, height. Two pi, radius is x, the height is 3x minus x squared dx. And you're going to integrate from 0 to 3. So you can distribute. Okay. So pull out your 2 pi, 0 to 3, 3x squared minus x cubed dx, 2 pi, Now, here's what we can do. Okay, 27 times 4. So it looks like we're going to get 2 pi 108 over 4 minus 81 over 4. Excuse me, 108 minus 81. So this would be 27 over 4, which is 27 pi over 2. There we go. So there you go, ladies and gentlemen. Region bounded by x is the square root of y. So here's the curve. X is the square root of y. X equals 0 is the y-axis. And y equals 1. So this is my bounded region now. Okay, so notice what they're going to say now to do here. You're going to revolve this about the x-axis. Now, how this is different than before is, notice they're giving you x is some function of y now. And so our approximating rectangle is actually vertical. And that difference is a dy, delta y there. And so when you rotate now about the x-axis here, what you'll end up getting now, you have this rectangle. And you should probably write a, I'm sitting at an angle here. probably do a little bit more accurate sketch of a cylindrical shell. And so here's an example of that cylindrical shell that we're looking for. However, let's remember how this formula looks again. The volume is going to be the integral 2 pi RH still, but now this is dy. Okay, because if it's about the x-axis, which you'll see is this dy is, this delta y will be dy. And the key again is to find your radius value and your height for the cylindrical shell. So this time, the radius, though, is a y value. They're talking this radius here in orange or red. That's the radius of the cylindrical shell. So if we say, what's the distance between these 2 points? Well, it's the corresponding y value minus 0 because it is top minus bottom. This is how we measure distance. That is vertical. So our radius here is going to be y. The question becomes, what's the height now of this approximating rectangle? So we can look at some points again, here to here. This is going to be the height now of that approximating rectangle, and it's a horizontal distance. So we measure horizontal distance by the right value minus the left value. So it's y, let me apologize. It's going to be this right value. It's this x r on the right minus x l on the left, or we should simply say, we get the right color, our height is the curve square root of y minus 0 here. Okay, because the y-axis, again, if we said, well, how did we get that? This y-axis is x equals 0. It's the vertical line x equals 0. And the purple curve that you see here, if it is purple, yes, I think it is purple. That's given to us as x is the square root of y, and that's on the right. So you're taking right minus left, and there are x coordinates there. So that your height here simply becomes the square root of y. Now the question becomes, this is over C to D again. This is C to D. So this is on the y-axis. So as you can see here, this is going to be from 0. This value is 1 by the geometry. So this is for the y values being 0. Y values being 1. And remember, this version of cylindrical shells is given to us as a summary in our worksheet here. If we go all the way back, we're now evolving about this y-axis. Cylinder method. Sorry. It's over here. I'm sorry. Over here. Let's find it. X-axis right in here. And that, you guys know, should be y. So this should be a y there. Okay? So again, this is what we're doing. Okay. Volume 0 to 1, 2 pi, radius is y, and this is times square root of y dy. Y to the 3/2 dy. Okay. Apologize, just looking over my notes here. 2 pi, 0 to 1, pull out your constant. 2 pi, y to the 5/2 over 5/2. 0 to 1. 2 pi times 2/5. 0 to 1. 4 pi over 5, y to the 5/2, 0 to 1. So the answer is going to be 4 pi over 5. Okay. So let's do the next one here on this list. Just checking our time. Now we have a curve x equals f of y again. And it's about the y-axis. So I think we also have x is 0, right? And that's going to be, sorry, that's the y-axis, so you guys know. So what they're saying here is you have the y-axis and you have this curve. They're talking about a bounded region. This is the bounded region here. And you're going from 0 to 4. You know. So this is y equals 0 to y equals 4. And there you go. So here's our approximating rectangle, and it doesn't look too much like a rectangle. So let's try that again. So let's draw the approximating rectangle again, and that's going to be a vertical strip. There's your delta y. So again, volume integral 2 pi RH dy. Okay, you can verify that here, here, here. And you revolve this about the x-axis now. On the other side, this is what you get. And my art skills aren't the best. I apologize there. So this is the cylindrical shell we're referring to. And we need the radius now. Right? The radius is going to be from this point essentially up to this point. That's our radius. This is what we've been finding here in orange. So we let this be an arbitrary y value. And remember how we find those kinds of things where the radius here is now a vertical distance question. So it's the top minus the bottom. So it's y minus 0. Or the radius is just y. And this is what we're saying in orange here. Because there's y here, and this is where it's 0. So it's an arbitrary y value up here. Y minus 0, and that's for our radius. And the height now. So your height will be, essentially, if we can see it, here to here, that green distance, it's not a perfect picture, but okay, something like that. And we can go back if you wanted and shrink. Can we get to that? Maybe it's under. Yeah. Shrink that whole distance. It's okay. Remember, that's a horizontal kind of question. Horizontal. Right minus left. Now, the right is the black curve. So it's XR minus XL, the left curve. So you say this is the right curve, and this is the left curve. This is XR, this is XL, if you can see that. XL is 0. So we have 4y squared minus y cubed. Height is 4y squared minus y cubed minus 0 here. So we can kind of see this right curve, left curve. Okay. XR, XL. Height is 4y squared minus y cubed. Right, left. So the volume is going to be 0 to 4, 2 pi y, 4 y squared minus y cubed dy. Radius, height, dy. It's double checking. So the volume now becomes, if you pull out the constant, 0 to 4, y times 4y squared minus y cubed dy. And you can actually distribute here. 4y cubed. Yeah. Y to the 4 dy. And I think we forgot the 2 pi. Okay. 4y to the 4th over 4 minus y to the 5th over 5, 0 to 4. Okay, let's kind of find this. So let's do some arithmetic. 1280 minus 1024. 256 over 5, maybe. So the volume would be double that. Looks like it's 312 pi over 5. Sorry, 512 pi over 5. There we go. So you get your cylindrical shell, ladies and gentlemen. You need your radius and your height, and that's kind of the key. And let's try one more here. So what you have here is, again, bounded area. You're rotating here. This is some function x equals f of y and x equals g of y. You're rotating about the x-axis. So this looks like this is where 3 would be. That's y is 0. Your approximating rectangle, again, is going to be vertical. So remember, this is XR, XL. That's going to be an important detail. Because when you rotate that region about the y-axis, you obtain a cylindrical shell. And for this particular y value, we need a radius. Again, a vertical distance. Vertical is the top value minus the bottom. We're going to let this distance be y, and that's 0. This is where the radius would be, right? This is a radius value for this cylindrical shell, so it's going to be simply y. So the radius here is y. So we want to now check the height. The height here of this approximating rectangle, again, is that horizontal distance, and we measure horizontal distance by a right value minus a left value. So we can say that XR minus the XL, but they're curves. You have the blue curve, which is a parabola. So that's this curve right here. It's the x equals 4 minus y minus 1 squared. So we say 4 minus y minus 1 squared minus, and that was the blue curve. Minus the other curve, which is green. So this will be x equals 3 minus y. So this is going to be 3 minus y. So let's do some simplification here. This is going to be our height. So 1 minus y minus 1 squared. 4 minus 3, this will be plus y. So if you want to do some algebra now, maybe this is a good time. So this would be y squared minus 2y plus 1 plus y. 1 minus y squared plus 2y minus 1 plus y. And 2y, it looks like it's 3 minus 1 is y squared. So this is going to be, I guess, the green, whatever. Green and green. Orange. Starting to lose track of my colors here. Anyway. Volume. 2 pi r, we've seen r going to be y, right? Up there. So this is y. H. Ultimately 3y minus y squared dy. And that's going to be from 0. Your y value goes from 0 to 3. So it's 0 to 3 integral here. Yeah. Okay. So we'll pull out the 2 pi from 0 to 3. 3y squared minus y cubed now dy. Okay, let me double check. 3y squared minus y cubed. Okay. And we get volume is 27 pi over 2. And there we go. So let's see, maybe number 8. Notice what's going on with number 8 here, possibly. And looks like all the picture just didn't come out for number 8. Notice they're saying for 8, what's the bounded region for this parabola? Y is 0. Well, that's the x-axis. X is -2 to -1. So it looks like I didn't get this picture complete like I should. So here's kind of the bounded region here. Just so you guys know. this is what they're referring to. But notice we're back to revolving here about the y-axis in this question. And, x is from -2 to -1. So volume yet again here will be the integral from -2 to -1. So I started it. We have to do smaller minus larger, okay? And that's going to be 2 pi RH dx. So -2 to -1. And when you draw the approximating rectangle, make sure something like that. Okay. You have this x. So we want to kind of talk about this here a bit. Okay, we need a radius now. Notice this. This is an important thing. You get 0 and this point here. So let's kind of look at this in some detail. Let's keep our wits about us. This isn't a random, not a random, sorry. This is an arbitrary x value, and this is where x is 0. So when your radius here is the right value minus the left, this is on your right here. This is on the left. We're measuring distance. Distance measured horizontally is right minus left. So take a look. What's very interesting is that your radius here is a negative x value now. That's how you measure distance. That's horizontal. That's the radius. Now, I apologize in that I did not, let's see if I can do this. I didn't rotate this. We didn't rotate that together. Copy. Let's see if we can get, there we go. I want to move it all. I guess I can't. I wanted to show you your cylindrical shell, okay? So that horizontal distance is our radius, so that's why it's a negative x here. Very interesting. That's our radius now here. The height of this, again, is top, y top minus y bottom. Okay, that's in green, I guess. The top portion is the parabola curve. The y is x squared. So for height now, you say y top minus y bottom. That's the x squared minus the 0 because, the x-axis is, this is y is 0 here. So this is like the top. Let's make sure we spell top correctly, not tob. And this is bottom here, so you can take a look. The x-axis is y is 0 here. So you have top minus, here's the top value minus this is y bottom. So it's just h squared. So here's my height. And that's in green. Okay. So there's your height. So let's see what this volume is going to be. -2 to -1. 2 pi -x x squared dx, which becomes -2 pi x squared negative 2, negative 1. Negative 2 pi x cubed dx. Negative 2 pi x to the fourth over 4. Negative 2, negative 1. I'll say negative pi over 2 x to the fourth. Negative 2, negative 1. Which will be negative pi over 2 minus negative pi over 2. So negative 2 to the fourth power is a positive number because that's an even power. 2 times 2 to the fourth power, 16. And that's the parentheses. Negative pi over 2 looks like it's plus 8 pi. Right, 2 over 16 and that minus the minus. So what we can do is multiply this top by 2, bottom by 2 to add so we should get 15 pi over 2 now here. And ladies and gentlemen, I think we'll call that a morning here or a night or whatever time of day it is, at least for us here. I think this is some pretty good additional examples to get you guys started here. So anyway, ladies and gentlemen, I hope you enjoyed this. Take care, stay safe, and you have a wonderful day. Okay, we're going to look at number 9. Number 9 is a different question than what you've seen here. What I want to point out is, yes, you have a curve here. You have a parabola. In fact, you have two parabolas. They both open down. And the region that they're describing here, if we notice this, got this point of intersection and this point of intersection. This is at x equals 0. And here this is at x equals 4. So we want the bounded region between these two parabolas that open down. And what you see here is exactly the bounded region. So we're going to have to determine which parabola is the top, which is the bottom. Because if you really notice, you're going to revolve this curve around x is negative 2. So this is not the y-axis. This is x is negative 2 now. So this is how it's different. So instead of revolving the curve around the y-axis, you revolve it around the vertical line x is negative 2. So that when you draw your approximating rectangle, right in here, this portion still, you're going to have that delta x for some x value between 0 and 4. So we know x is between 0 and 4 here. But what you're going to do now is you're not going to revolve this around the y-axis. It's the line x is negative 2. So on this other side, if I can copy this, let's see what happens. Okay. And actually further away, I guess. So I'm just going to draw my picture here of, your cylindrical shell. So as you can see, it's still a cylindrical shell type of question here. So the volume now, remember, this is going to be the integral of 2 pi r h dx. Where you go from 0 to 4, this is how my x value will change. Now, I still need the radius here. So I have my radius, and I need my height. So I always need those two important things, the radius and the height. So what I want to remark here, again, is a detail that's different than what you've seen. You're already aware that your radius will be the right value minus the left value. So if this is the arbitrary x value, and this is x is -2, this is on the right, and this is on the left. So you have x minus -2, because -2 down here is the left value. So your radius now will be simply x plus 2. It is the right value minus the left value. As a height value, since we found the radius, that's different. We haven't seen that till now. Your height value is going to be these values over here. So for that x value, we have this y top and the y bottom for this particular value of x. This is going to be the height of our cylindrical shell. So y top minus y bottom. So that height, we have to determine the purple, which is on top parabola, and that has a vertex going on, up, that's higher than the vertex for the green. So just to kind of point out to people here, if I just take the first curve here, just that first curve on the left, I'm going to factor out an x value, and it means I have my intercepts at 0 and 4. Well, they both have the intercepts at 0 and 4. So here's what we probably want to do. Let's remember, for the vertex, there's a nice x value and a y value, right? How do we get the y value for a vertex? If you guys recall, what you can do is c minus b squared over 4a. That's going to be the y coordinate value of the vertex. That's when you let x equal -b over 2a. So in this question, a is -1, b is 4. So I can try to deduce what that would be. C would be 0. So 0 minus the b value, 4 squared, 4 times -1. So for that first equation, we have -16 over -4, or y is +4. And that's where this y coordinate of the vertex would be at +4. So that first equation is the green curve, the green parabola. And that happens to be on the bottom down here. So that implies that the second curve in purple, or the other curve, will be on top. Okay, that's helpful. Top minus bottom. 8x minus 2x squared minus the bottom curve, which was green, the first curve, 4x minus x squared. And this is our height. So the height will be 8x minus 2x squared minus 4x plus x squared. So we're going to simplify my height here. Let's double check. Okay. 4x minus x squared. So this is our volume now. The integral from 0 to 4, 2 pi r x plus 2 h 4x minus x squared. So you have the radius and you have the height. Okay. 2 pi integral 0 to 4 x plus 2 4x minus x squared. So you're going to use some algebra here. You're going to use some FOIL. First term will be 4x squared. Outer term, minus x cubed. Inner, 8x. Last, minus 2x squared. 8x plus 2x squared minus x cubed. It's dx. Okay. Four times 4 squared. 2/3 times 4 cubed. 1/4 4 to the 4th minus 2 pi. And what I'm going to do here by now, hopefully you can just see that this portion here will be 0. When you plug in that 0 for every one of the values here. Okay. 2 pi 4 cubed plus 2/3 4 cubed. Looks like minus 4 cubed. Let's double check our arithmetic. Yeah. Which is 2 pi now times 2/3 4 cubed, which would be 4 to the 4th over 3 pi. Let me double check. And that's 256 now. Thirds pi. All right. And there we go. Okay. So the last question here, number 10. We're going to have a bounded region again. The curve y is x squared, which is in blue, and x and y squared, which is in black. And so the bounded region here is what you can see now, right in here. So we have a point of intersection. This is 1, and this is 1. But in this example now, notice what we're going to revolve this bounded region by. It's the line y is -1. So I'm going to put down here y is -1. So this is what we're going to rotate this region by. So when we put our approximating rectangle, the approximating rectangle is going to be horizontal. And that makes this a dy, where y is going to range from 0 to 1. Okay. So on the other side here, if we can try to sketch some of this, maybe we'll copy again. Somewhere like here. And as you can see, we create a cylindrical shell. Now my art skills are not the best, and I don't want to cover that too much. Remember, this is 1. But we get, again, a cylindrical shell. So that my volume becomes the integral from the y value is going to go from 0 to 1. So we have this arbitrary y value. And it'll be 2 pi r h dy now. Okay. So remember, we're going to need a radius and we're going to need a height that we've been getting. So my radius value now, if we look at the radius here for the cylindrical shell, and in all honesty, I really don't like my picture. My picture looks more realistic if I bring it kind of way out here, by the way. And I'll share with you why. Something more like this. Now let me share with you why. The radius value, if we revolve about the line y is -1, remember how we find a vertical distance? That's top minus bottom. Top minus bottom. So this point here is y. This point over here, this is y is -1. We already know that over here. So top minus bottom is y minus a -1. Top, bottom. This is how we measure vertical distance, so that the radius becomes simply y plus 1. So similarly, for that particular y value, okay, we want to find now the height here for this y. That's the height value. We want to find this, what we call horizontal distance. So it's going to be, remember, right minus left. So that's going to be XR minus the XL. The right curve minus the left curve. And on the right-hand side, in terms of X, it's the blue curve. But you have a problem here. We have y is x squared, which means x will be plus or minus y. which means x is the square root of y, or x is minus the square root of y. So we're going to use here the positive because it's in quadrant 1 and all points in quadrant 1 for x and y are positive. So this is going to be what we have to use for my right portion here. This is the right portion here in blue. So that's the square root of y. Now minus the left portion of the curve, which is here, and that's in black, which is y squared. So this will be minus y squared. So my height, the square root of y, minus y squared, and this is in green here. So this is the information that we need. So it always comes down to getting these distances here, left and right, top and bottom, finding really how to measure. So I plug all this in my integral. 0 to 1, 2 pi. Radius is y plus 1. The height is square root of y minus y squared. And this is dy. Radius, height. All right. So pull out your 2 pi. We're going to integrate from 0 to 1. But, I'm going to have to use a little bit of algebra here. So that we can integrate. So this will be by FOIL. Y to the 3 halves, first outer, minus y cubed, inner. Y to the 1 half, last term, y squared. Okay. Y to the 5 halves over 5 halves. Y to the 4th over 4. Y to the 3 halves over 3 halves. Y cubed over 3. And that's from 0 to 1. Two pi, 2/5, y to the 5 halves. 1/4 y to the 4th. 2/3 y to the 3 halves. Minus 1/3 y cubed. We go from 0 to 1 here. Now, I'm going to do the same thing. I'm going to plug in the 1. And that's 2 pi again times that 0. So that's the nice thing about working with 0. And then 1 to all these powers that you happen to see here. All of these numbers are 1. So you'll end up with 2/5 minus 1/4 plus 2/3 minus 1/3. So we'll start to do our arithmetic now. 2/5 minus 1/4, and it looks like that'll be plus 1/3 here if I combine the last two. 2/3 minus 1/3 is 1/3. Now I need the LCM here of 5, 4, and 3. So it looks like it's going to be 60 or 30. Anyway, we can, looks like it's 60 times 12. That's 15 and 20. Let's double check. Okay. 2 pi, 24 over 60, 15 over 60, 20 over 60. 2 pi. Now I have to add my numerators. 24 plus 20 is 44. And then we have 44 minus 15. Looks like that would be 29 over 60. And then finally, it looks like the volume will be 29 pi over 30. Let's double check. And there you go, ladies and gentlemen. This is how you find the volume by cylindrical shells when you, in fact, are not going to rotate either about the x or y axis, but along vertical lines, y is a constant, or, horizontal and vertical lines, x is a constant, like we did in the last two examples. So, ladies and gentlemen, that concludes our volume by cylindrical shells. I hope you enjoyed the demonstration, and stay safe.